right, so here we're going to have a discussion about fractional equations and extraneous solutions. Some of the problems that we've had before, you could just plug in, you could resolve the fractional components of it so that you could get to a quadratic. And if you get to a simple quadratic, then you can use the quadratic formula and then test to see if any of those solutions are going to be extraneous solutions. But here, we're going to handle this one just a little bit differently. This is one of the problems from your book. So what we notice here, first in the denominator, I'm going to say you notice that if I look at this, if I multiply these two together to get a denominator, then I notice that this is also the difference of squares. So what I realize is that I'm only going to be dealing with the numerator of this equation because once I have a common denominator by multiplying this side by x minus 4 and that side by x plus 4, then all I'm dealing with is that numerator again. So the first thing I do, though, is I figure out what my excluded value is. My excluded values, as we can see here, are going to be -4 and +4. So that's why I have them down here. But even though I do them first, because you can do them when you plug it in and look for extraneous solutions. But nevertheless, so we're going to find the domain, solve, and find any extraneous solutions. So let's, this is going to be kind of easy. So we're going to multiply x times x minus 4, and then we're going to add 4 times x plus 4, and you'll see that I have that there. And then we're just going to resolve that to the numerator here, x squared plus 16. By distributing out this x, I get x squared minus 4x, and then I get 4x plus 16. These 4x's cancel each other out. That's why I've done that. And then what we realize is that we've got x squared plus 16 is equal to x squared plus 16. Well, once we get that, we realize that the solution set is going to be the set of all real numbers. And so that makes life a little bit easier. And our excluded values here are going to be still negative and +4. So that one was kind of easy. We've got another one right here from your book as well. And this one's not quite as simple, but easy enough to solve if we do it bit by bit. So like I said, I like doing my excluded values first. And so my excluded value here is going to be -5. And my excluded value, so if I set this equal to 0, then x is equal to -5. And that would make it impossible because it then ends up undefined. Similarly, if we set 2x plus 7, that'll also make this equation have difficulties in being undefined. And therefore, x cannot equal -7 divided by 2, so -7 halves. All right, now, well, let's deal with this side of the equation. If we deal with this side of the equation, we have to have that common denominator. It's going to be x plus 5. So what we'll do is we'll multiply 3 times x plus 5. And we'll take away that 22. I just consolidated these in the numerator, put it over x plus 5. We left, or I left, this side of the equation the same, but because we realized that we've got something simple enough that we can cross multiply, so we're going to cross multiply. And if you notice that we have 6x minus 1 multiplied by x plus 5, that's what I've put right here. And though this side is a little bit more awkward looking, it's just this 3 times x plus 5 minus 22, all of that multiplied by 2x plus 7. Now I could have distributed it on the fly, but I just decided not to. So here we have 3x plus 15, and then taking away 22, which is the same thing as saying we consolidate 15 and -22 and we get -7. So 3x minus 7 multiplied by 2x plus 7. And that's all equal to whatever this foils out to be, which just happens to be 6x squared plus 30x minus x, and then minus 5. those like terms. Take 1 away from 39. We're going to have 6x squared plus 29x minus 5. Right, now we're going to FOIL this side, because this is just going to be dropped down, and then we'll do some the solution there. So let's FOIL this. It's going to be at 3x times 2x is 6x squared. Then we end up with, I think I did the inside first here. So negative 14x, positive 21x, and then negative 49. We gather up our middle terms, which end up with positive 7x. So we have 6x squared positive plus 7x minus 49 is equal to 6x squared plus 29x minus 5. Now, what I've already done here is canceled out. When we have that 6x squared on either side, we don't even have to deal with them. And what I'm going to do here is I'm going to set this side equal to 0. And in order to do that, I have to take away the 7x and add 49. And if I do it to one side, I'm going to do it to the other side here. And once I do that, I'm going to end up with 22x and 44. So in order to solve for x, I'm going to chuck 44 onto the other side. So I'm going to have negative 44, and then I'm going to divide by 22. Negative 4 over 2 is going to be negative 2. So we know that negative 44 over 22 is negative 2. But we're not done yet. So what we're going to do is we're going to take that x equals negative 2, and we're going to plug it in. And we'll plug it into the original equation. Now, some people, this is where they try and figure out their excluded values, and that's fine too. But what I did was I'd already done that, so I don't have to worry about that right now. So I plug in my negative 2 for x here, and that's negative 2 plus 5 is going to be 3. And then we have to make sure that if we have 3 at the bottom here, then we're going to have 9 over 3. So you have to change. That's one of those areas where people might get tripped up. And then we're going to plug in on this side over here the negative 2, where we'll have negative 12 minus 1, negative 4 plus 7. We're going to have negative 13 over 3. And when we take away that 22 from 9, we're going to end up with negative 13 over 3, which means that x equals minus 2 is a valid solution. It's not extraneous. And then we have to, in the solution for this, we have to also identify what cannot be a solution. And that's negative 7 halves and negative 5. Hope that helps.